哇，对，好像是哎，不是
Hello,
因为
who is there? Just please all make sure that that you are muted unless you want to talk. So just unmute yourself if you are not talking, because we can get echoes from your speakers. We can get emergencies on the street in front of your house, and also all sounds that wouldn't be nice.
Hi, Marie, how are you?
Hi, I'm good. How are you?
Good, thanks. So thank you for sharing this session. Are you
Thank
ready?
you.
Are you ready?
Thank you. Yes, yes, I am ready. And there, nobody has questions. I've emailed on all participants, I believe. Please scream now if you didn't receive my emails. Anybody hasn't received my emails? So just as people are joining, I am repeating again. We will first go through each presenter, having 2 to 4 sentences about yourself and about your paper, and I would like to ask you to share the screen and just go through the presentation, be a bit visual. And I asked all of you to prepare a question for a paper of your choice. So after we go through the presentations, we will you will get space to ask people the questions. So I hope everybody has a question ready. If you don't, you have 15 minutes to do so. So think if you forgot about that, just fast think of a question, because we need some discussion. And again, if you are not talking, mute yourself. It's a button on the bottom left. Share your screen with the green button in the middle down. If you have any questions or queries, please talk now. And I really have to excuse myself. I will probably pronounce your names incorrectly. So just feel free to correct me. And also for a discussion, if you would enable your cameras, would be nice, so people see faces instead of the title of your names. So please, you enabled your camera on the bottom left hand side. So please show your faces as much as you can in case you have a webcam. If you don't, never mind. Hello.
Hi.
So we have last minutes to ask questions. If anybody didn't receive my emails, please scream now. Otherwise, I hope you all are ready. There were no queries to my emails, so I hope nobody has a problem with the way we are chairing this session.
I heard that Garvin had a problem finding this message from you and the
Yeah,
link.
I got contacted by him and I forwarded everything to him. So I believe it should be all right.
Okay. Hopefully he wakes up.
Yes, because I think so, because he messaged me asking me for the link to the session. So I think he is awake.
I think he's in Germany right now. So.
Yeah. I'm in Cardiff, so I'm even 1 more hour earlier.
I joined a webinar this morning at 5 a.m. Hong Kong time, hosted in Detroit, about how schools are handling, architecture schools are handling specifically online learning. I don't think very well. Incidentally.
We are getting there. We are getting there. I mean, I'm definitely much more advanced than I was half a year ago. I learned a lot of new tools, and many of them I will use even after this is over. So it enabled me to learn new tools and combine. Otherwise, I wouldn't dare. I was too much in my comfort zone. I didn't dare to learn all those tools, just use them as they were. But when we got into lockdown, we started exploring what we can do with those things.
Ah, there he is.
Hello.
Hello.
Hi, everybody.
Hello.
Hi, Maria.
Change your name, Garvin.
Oh, shit. I got your wrong link, I think. Where do I do this? One second.
Maybe in your Zoom settings.
Yes. One second.
It's a question if you can do that, because I sent you obviously my link.
Yes.
So that's probably the problem.
No, it's good. Thanks.
Excellent. So as I said to everybody last moments to ask questions. Yeah, you obviously received my emails because I was forwarding them to you. So so you, Garvin, you are up to date. Any questions, queries, please scream out now. We have 8 minutes till start. Everybody knows how to use Zoom. Question. Everybody knows how to use Zoom. Everybody knows how to share the screen. Everybody knows how to mute and unmute. please don't be shy and ask now.
Yeah, do you mind holding like a dry run just to let us know what's going to be the order of presentations? I might have missed it because we joined a little bit late.
Okay, the order of will be, I will follow the order from the program. So I will put the program into chat. So this is the program. I will go directly from there. And yes, I to many of you. This was to Mink. Oh, sorry, all participants. So this is the link to our session. Scream out if you are not there. So we will go one by one. Please don't be too long when presenting your paper, because we want to get to questions. So so
second question would be, sorry, I'm not shy as you suggested. Second question, how long is it going to be each presentation?
Please say your name, where you are from, and say 2-3 sentences what is the paper about, and scroll through your presentation so people, or for 4 sentences maximum, just to make brief introduction what it is about, so we have time for questions.
Perfect. Thank you.
Give it time limit, but I mean, please don't take too much of space, because then you are taking it from somebody else.
Here for the theory and philosophy.
Hello? Somebody was asking anything? No. Okay. So just repeating, as I said, please, if you are not talking, mute yourself. That's the button on the bottom left. Share your screen with the green button on the bottom central. And make sure that after you go through your presentation, you unshare your screen. We have a bit of time pressure, so straight after you are finished, just unshare your screen. If anybody wants to test how is it to share the screen, please do that now. Just share the screen and see what you have to do. And please start introducing yourself while you are already pressing the button on for sharing the screen, so we don't have too much, don't spend too much time in the meantime. We have very big time pressure. It's many of you, and many exciting discussions to follow. So please be as time efficient as possible.
Hi, Marie.
Hello.
Hi, this is Patrick here. So I've got my student Derek is trying to get into the presenters. He's at the moment, he doesn't have the link, and we already.
Okay. Can you pass me his email? I will forward him the link.
but he needs the
From the
link.
tech support.
But he needs the link for the presenter, not the link for the attendee, right?
Yeah, but that's what I can forward
Yeah,
to you.
there's somebody on while Ipon is on tech.
Let me help.
Yeah.
Yeah.
He should be logged in with the email that he provided us before, so he
But
can.
he did. So he should just log in with the email as using the normal link.
Did he give us email?
Yeah, he sent an email saying, "Can you add me?" And then you replied saying, "Yes, we will add you." It's Derek Pung.
1 second. Or you can give me his email. I'll add him as a panelist.
Okay, how do I do that? I give it
In
in the chat.
Yeah, please.
Yeah, do that in chat.
IDEX tech support.
Can you send to panelists? I think it's
Yeah.
a primary, and we should start so we don't waste your 45 minutes time, Mary.
Yeah.
Okay. Well, we have two more minutes, so let's just. Okay.
Okay, I just sent you the link, the email.
The email, yes.
Yeah.
Okay, so I will start my timer.
Yeah. We are on practice mode right now, and I'll start broadcasting with a countdown timer for 3 minutes with the music on. Okay, everybody ready?
Yeah, everybody ready? So I will stop hearing the music when I should start, right?
I will have the music on, so please mute your mic for now.
Yeah.
And then when the time is start, so Mary, you can go ahead and welcome everybody, all the audience in. Yep. Okay.
Hello, welcome everybody. My name is Maria Davidova and I'm chairing this session. This is session 7 that is called Human-Computer Interaction, Collaborative and Collective Design, and Computational Design Education. So we have 3 topic areas for this session. And we need to be very time efficient because we have only 45 minutes and many papers. So I will just briefly explain how this session will be chaired. We will go through each paper. Every presenter will introduce themselves and say briefly in 2 or 3 sentences what is their paper about, and scroll to the visual because visual is very important. And then we will start having a discussion. So I will not waste too much of the time, and will ask to Tom and Karen to introduce themselves.
Good morning. I'm Tom Shaked.
Karen Libar69.
We're from the MTRL, Material Topology Research Lab at the Technion Institute of Technology in Israel. We'll present Autonomous in Craft, our paper, facing a decline in manual craftsmanship in architecture. We explore the potential of future autonomous craft. Forwarding this notion, we will present 3 concepts. First, documenting the gestures of local craftsmen. The second, augmenting a robotic fabrication tool with custom end effector and sensor toolkit. And the third, enhancing the fabrication protocol with material and spatial awareness, producing autonomous fabrication protocols and processes. Thank you very much.
Thank you. I would kindly ask you to unshare your screen, and I will ask Tian Tian and Xinrui, or I have to excuse myself. My Chinese is not the best. So
no
please,
problem, no problem.
Thank you.
Okay. Okay. Hello, everybody. I'm Sky. You can just call me Sky. I'm from Harbin Institute of Technology, Shenzhen. So my research is to look at the difference between human-computer interaction to human VR interaction, and in the context of digital architecture design. So I will just run through the PowerPoint. So we are looking at how pens and pencil to, how we are using keyboards to, detect like hand body gesture, and then how it actually change, the way we interact with the design online. And then, of course, right now, VR is very different in the sense that, we are only looking at, it's much more on a visualization. The interaction is not very rich. And then, how we actually look at HVRI. So in this paper, I actually explore the various from VR, AR, MR to even XR. And I mean, this is good. After I go through these papers in this session, you can see how all these the interaction, how all the various researchers actually interact with the virtual environment. Like the previous, just before me, they use the real objects and then, connect it with, link it with the virtual environment to see how it actually works. So I think we can actually have some discussion in how the interaction between whether should we go more virtually, or should we actually integrate within the real and the virtual environment, or how it actually and if all this integration, how the interaction, basically the point is how the interaction actually works. So yep, that's all from me.
Thank you very much. Now I will ask Banu and Tian Tian and Xiangming. If it even relates a bit to how you pronounce your name. If not, please go through the program and understand that it's you. Are you there? Is Vanu Pei, Tian Tian, and Xiangmin here?
Yes, I'm here.
Yes, yes, please, if you could introduce yourself. Sorry for the pronunciation.
Okay, let me share my. Oh, sorry. Please wait for a minute, and I want to share my screen. Oh.
Yeah, there is something not working.
Yes.
Maybe because we don't have too much time. If you could just introduce the paper without the screen sharing.
Okay. Okay. Now. Okay. So I will introduce my paper without PPT. So hi everyone. I'm Pei Wan Yu. I'm from Harbin Institute of Technology, Shenzhen University. And my paper, I want to introduce my paper briefly. And the topic of my presentation is by precise detecting architectural space with the integration of emotion recognition and eye tracking technology. And we all know it's necessary to study the influence of not only the built environment on people, but also people's feedback on environmental design. So this study explores the process of interactive design using both emotion recognition and eye tracking of users. So by putting on wearable device to roam and perceive in a VR space, so the physiological data of users can collect it in real time by and used to analyze their emotional response and visual attention to the space. So this method will provide a way for non-architectural professional users to participate in the architectural space design. So at present, this is a link of research on the combine of applying eye tracking and emotional feedback in architectural space design. So for this paper, we review some research and proposing an interactive design workflow that use eye tracking and emotion recognition. So this workflow will help with the next stage of research to understand the design of new international school of design building. So recently I have—
Maybe if you could speed up a bit because we have we are very limited in time.
Yes,
if
yes.
you could just conclude, yeah.
Yes, I have finished, and in the future we will use this case study to work on this workflow and to research on this workflow in deeply. Oh yes, thank you.
Okay, thank you. Thank you. Now I will ask Zhirong and Teng Beng and Ji Xin. It's
that's right.
It's probably very wrongly pronounced, right?
Yeah. Okay, I start. Hi everyone, I'm Jurong Lu from National Yulin University of Science and Technology in Taiwan. And in my research, we propose a horticultural game design, high game system. Now elderly people living alone and their children living in other places can use the Internet of Things to plant together. Connect the different places in space to improve the emotional communication between elderly living alone and their children. High-gain target is to increase the frequency and internet interaction to increase the well-being of the elderly. In the high-gain interactive planting research, we explore the psychological healing effects that horticultural planting behavior can bring to the elderly. Yeah, thank you.
Thank you. If you could unshare your screen, and then I will ask Galok and Yeren if you could go forward.
Yes, hi. I will present if I can share the screen.
Yes, you can just start introducing yourself in the meantime.
Yeah. So I'm presenting on behalf of Tim Chow, my master student in the MArch program in the Chinese University of Hong Kong. My name is Jeroen van der Meijden. This project is titled Generative Housing Communities, Design of Participatory Spaces in Public Housing Using Network Configurational Theories. It's a research by design project that explores how we can understand and redesign public spaces in housing estates using qualitative and quantitative analysis of circulation networks. Because in Hong Kong, housing estates are designed around efficiency, which severely limits the flexibility of use, and have a certain social regimentation built into them. We look at Hillier Hansen sociological space, including shortest path, visibility integration, connectivity integration, to try and predict social interaction and offer more freedom of choice through allowing to take different pathways. So the outcome is supposed to create a platform for self-organization where the residents have more chances to appropriate space because of the nature of space is more different through the different levels of privacy. That's it.
Thank you. Then I ask Metz Brat and Abhishek if you could share your screen, introduce yourself. Are you there? Mats and Abhishek. Maybe my pronunciation is not the best, but please follow the program so you see. Nobody there? Unmute yourself, just to, okay. Okay, well, then we just continue and we ask Michael, Oliver, Amanda, Marcus, Clement, and Lynette.
Hello, I'm Michael. Give me a second to share my screen. Can you see my screen?
Yes.
All right, so hello everyone. I'm representing a team from Singapore University of Technology and Design, SUDD. And this is part of a research that we've been conducted for 2 years, which is discussing a data-driven embodied carbon evaluation tool for early building design iterations. So I assume we all are familiar with the fact that 40% of the global greenhouse gas emissions come from the built environment, and a lot of effort is on operational carbon, but not so much on embodied carbon. So we tackled that issue. And we also know, at least those of us who've tried, that all the software is very fragmented, and we need very complete data in order to do some sort of life cycle assessment or embodied carbon assessment. So what we have worked on is a simplified process that could be applicable in very early design stages, where we take generic design parameters and through data collection and the predictive modeling come up with a simplified LCA visualization tool. So we more or less collect data from existing floor plans and determine what the material quantities are. And then we have developed a grasshopper definition, a mock-up tool that allows you to choose different material ratios in support systems and infill systems. And we use Bayesian neural network systems to make predictive modeling based on that data. Bayesian neural networks always give an indication if the bandwidth is large. You cannot trust the data so much as if the bandwidth is smaller. So this is kind of a visualization, what we came up with. We are using a shoebox as a representation of the building, which we borrow actually from energy design processes. And yeah, we came up with we developed this predictive tool to evaluate embodied carbon. You can have a look at it at this link. It's in the presentation. And I'm also proud to announce that next year we will present part of this research at the Venice Biennale, so another venue where you can see part of this work related to this tool. Thanks, of course, to our whole team, and thanks to the attention here. Thanks. Thanks a lot.
Okay, thank you. Now I would ask Garvin and Christoph if you could go ahead.
Yes, so hello from my side and welcome to the short paper presentation of augmented reality-based collaboration, which is based on the Bamboo art installation case study Argon. The paper is authored by Christoph Kroller, who recently moved to Hong Kong University as an associate professor, and myself, Gavin Göppel. I'm a PhD student at the Chinese University of Hong Kong, focusing on the implementation of AR and MR technology into design and fabrication processes. Argon is a geometrically complex bamboo sculpture that relied on mixed reality for its joint creation by multiple sculptors and used latest augmented reality technology to guide manual fabrication actions. As part of the construction workflow, holographic setups were created on multiple devices, including a series of Microsoft HoloLenses and several handheld smartphones that were all linked simultaneously to a single digital base model to interactively guide the manufacturing processes. This paper critically evaluates the experiences of extending recent AR and MR tool developments towards applications that center on creative collaborative production. The paper concludes with a plea for digital technology's ability to stimulate dialogue and collaboration in creative production and augmented craftsmanship, thus providing greater agency and more diverse design output. Thank you for your attention.
Thank you very much. Then I ask Derek and Patrick.
Okay, hold on. Hi, can you hear me?
Yes, we can hear.
Okay,
you.
Yeah.
Can see your screen.
I'm Derek from National University of Singapore, representing the paper Automated Grading of Parametric Modeling Assignments. Our paper described the implementation and deployment of an automated grader used to facilitate the teaching of a spatial computation thinking course on edX, a massive open online course platform. We presented a scalable framework that deals with the automated assessment of 3D parametric models. The following short clip features the use of our automated grader. Okay, thank you.
Okay, thank you. Now it comes. Our paper. This is a paper I co-authored with Dermot McNeil. Can you see my screen? I hope so. So this paper is a work in progress paper about co-designing with blockchain for synergetic landscape. Basically, this work is aiming on cross-species co-living in urban environment. I will just scroll through that. So this is the critic, right? You would have divided land by wilderness and human beings, as is human beings wouldn't be part of the ecosystem, and we are trying to redesign the economy to integrate other species into into co-living environment. So we are asking the question, this is a river in New Zealand that obtained personhood. Obviously, the river cannot act on behalf of itself, but it's Maori people acting on behalf of the river, working in their aims. So we are asking, what if bumblebee get paid for pollinating your tomato, and then you extend the meadows for the bumblebee? So that is the question. We are generating those systems. It's research by design through teaching, and those scenarios are integrated in a real life projects. As saying a work in progress, the students are now about to deliver, and they would be designing various prototypical interventions for expanding habitable and edible landscape across the species, where we interact with DIY videos that interact with this blockchain system. So this is QR code to the blog where you can follow, and thank you. I will stop sharing now and ask the Adam, if you can start presenting, please.
Hi, can you hear me?
Yeah.
Okay. So my paper is really about entitled Integrating Design Studio Teaching with Computation and Robotics in Hong Kong. And I'm looking at kind of taking out the technician and the large-scale industrial-sized robots from the studio and integrating instead in the studio environment itself on the desktop with low-cost, small-scale, but high-precision equipment, specifically for my students here in Hong Kong. And this is really designed to break down a lot of fears that many students feel towards computation, programming, robotics, etc. And you may have experienced this yourself, where some students are entirely avoiding this entire topic. And what we're trying to do is kind of make it more accessible through more approachable equipment, using a series of workshops that allow them to, in a very free and problem-based way, look at how these types of robots can be applicable in their studio, in their design work as conduits for exploration. In particular, things like manufacturing process, pick and place operations, etc.
Okay, thank you. Then I will ask Dominic and Paul to give us short presentation.
Thanks, Marie. This is Dominic. I think Paul couldn't make it right now. I don't actually want to show our presentation. In the interest of time, we only have like 19 minutes left in this session. So, and our topic was rather a cultural topic about how we can avoid the sort of process of students becoming desensitized about the design process by focusing too heavily on the ability of tools. So our paper is titled Digital Stupefaction. We are questioning in how far there might be adverse effects of allowing students to work too freely or with not enough guidance when applying digital tools. And maybe I want to start a bit of a conversation. I hope I'm not taking away from you as a chair, to ask others if they maybe had any experience in their sort of work, in their education, where the application of digital tools can have an adverse effect on the architecture student sort of education. Of course, ultimately, we are all in favor of using digital tools, but we are urging other educators to be careful in how some of the processes associated to teaching subjects using digital tools, how that unfolds and what guidance they're providing. So I'm wondering, so I want to put that question out to the others, if anyone else has seen some sensitive issues that they feel they need to counteract in the way they teach.
Okay, thank you. That's great to start this question. I will actually relate to that. I am teaching in Master's in Architectural Design program here at the Berklee School of Architecture, and many students who come, it's postgraduate program, and many students who come actually are not able to make anything physically, or if they are able to make anything physically, it means printing out. I actually, you've seen parts of the prototypes. It was a lot of pain to force the students to put something in their hands and try to explore the craftsmanship, which could then inform their digital design. But you need to have those feedback loops between these things when you are doing research by design. Yes, I have to say I have struggled with that a lot, and I totally understand what you mean.
So how are you counteracting this? How do you, I mean, you mentioned physical models. Do you force them not to print things out and rather work by hands as well with mix the media? We call it a post-digital education. Yeah.
Yes, we are mixing media. We are drawing in hands. We are building things in hands. And I mean, if you print things out, it will. You've seen that weaving prototype. You will not make this weaving by printing. You might do that by robotics. It would take much more effort than to do that by hand. But if you want to develop it by robotics, you first have to do that by hand, to understand what is the process and what is the craftsmanship. So I am actually forcing students to put things in hand and trying to convince them that it's okay if it looks awkward because they are not handy. So they experience a lot of pain because they are used to produce beautiful, shiny visualizations and beautiful, shiny printed out models, so they feel terrible pain that actually when they take something in their hands, it looks very awkward very often, especially when they start. So explaining them what is design process, that things might look awkward and it's okay is part of the game, I believe.
Can I ask, put this question actually, because you were talking about robotics and everything. I think Adam, the paper, yes, because you were using mini little robots to teach the students, and you know, I'm just wondering how are the outcomes. You know, how does the student react to it?
Well, I think that the way I set it up, the outcomes are less important than the experiences themselves. So I really rig things to in a way that the students are set up to fail in that sense and learn from their failures. So one of the problems, for example, with using a technician is that there is a total handover of the material to that individual. And that unfortunately is the culture here in Hong Kong, whether you're at Hong Kong U or Chinese U, for example. So students don't get to access and troubleshoot and take on those risks associated with a hands-on situation. So I guess this in some ways is the premise behind introducing these low costs. So it's not really dangerous for the school in terms of finances, but also for the students. They're really not afraid of breaking the machines or doing something wrong with it, which in my opinion is the real start of any exploration. The other thing I would say is that the act of any making activity should be regarded as a design activity as well. So whether you're talking about printing, that in itself is something that requires choices and selection and calibration. And the minute you start thinking about your printer as a strictly output device, then you're no longer using it the way it could be used in an architectural sense. So whether it's a robot or a Grasshopper script or a Python tool or whatever, these are things that I want to push through my students in the context of failure and the creation of a kind of iterative knowledge gaining series of events. Design life cycle, maybe call it.
I would like to chip in some comments here because we have run a robotic studio here in Singapore with the Future Cities Lab with ETH Zurich a few years ago. And I think Adam pointed out one crucial aspect, that there is a huge distinction between printing, 3D printing processes and robotic fabrication. And I think in that respect, the scale doesn't really matter so much, like that you're working with rather small robots, but it's sort of a process that you need to actively engage with, and you cannot hand over the data to like a black box, like a 3D printer would be, or as architects would normally do, that you hand over the data to other people fabricating it for you. So I think that's a very interesting process. One thing that I've noticed is maybe not a really dangerous thing, but one thing that I've noticed, which was a difficulty, was more the expectation management on the student side. So that's actually something that I would ask Adam. Our students came up with comments like, when I'm going to work for an architecture office, there's not going to be a robot arm. So what am I going to do with that? And it's hard sometimes to explain the conceptual quality behind this kind of education. So that's something that's, yeah, as I said, like we had sometimes difficulties managing.
Yeah, well, there is a huge disparity between what students expect to be doing in architecture school than what they're going to be doing in an office. And my hope is that they're developing aptitude for problem solving regardless. I think that the accreditation board in the industry is looking for really good interns. But what I'm hoping for is leadership in any industry whatsoever. And that requires an aptitude for problem solving, an interest in curiosity and breaking things. And that is something that needs to be cultivated here and in other places as well.
I would actually say that it is a very important comment in the sense that, and we feel this pressure in UK, we are expected to produce employees for existing jobs. I think it's not our task. We should generate people who generates their own jobs, not get hired and become kid monkeys in the most boring office and becoming the most boring and depressed person on the world. So I would say that is quite important. We have one Q&A question that is to Tom, and please write your questions in the Q&As. To Tom, thanks for impressive research works. Sometimes human craftsmen accept failure of his hit and develop unexpected effects within it. What do you think about the feedback can be applied this interaction with accident of material more than achieving target geometry?
So first of all, thank you, Yasushi, for the question. I think it's exactly depicting the exact key to creativity. So he's really nailing it, as we have managed to predict the outcome geometries in a sense, and under a margin of error, we can now predict what the outcome will be. We have yet to explore or expose creativity to the level that error produces something more interesting. I think that's going to be post-automation or post-autonomy is maybe going to be the start of some intelligent creativity. And following artificial intelligence, maybe we can produce artificial wisdom in a sense of exploiting errors to your advantage. And I think this question kind of entails our future, or the future of fabrication. How could we manage uncertainties and mistakes to our advantage? So thank you for this.
Thank you. That's a great answer. That actually goes to my question to you, which is whether you are actually dealing. I mean, it is impressive research. Do you deal with the industry? Is it how do you link your research with industry, and is it getting implemented? Because exactly about generating your own job, it would lead to that you actually, there is a lot of impressive research, but much of that never gets realized because nobody really gets to know about it.
Yeah, so actually, thankfully, in our region, stone is kind of a very prominent culture. They build in stone. Actually, in Jerusalem, you're only allowed to build using stone. So there's a high demand there. And we have actually been working together with a couple of entrepreneurs and industrialists in order to kind of, on our end, try to conserve this practice, but on their end, trying to open their business for other markets and filling the demands they have. Because if they always say, once you had a bus full of stone carvers, today you can send a taxi and you only have one stone carver coming to the factory. And I think this is why maybe on the conservation end of the practice, super important, but also on answering demands. I think Singapore has it's the most density in the world, and they need stone. Jerusalem needs stone. So we're trying to fill that gap.
Okay, thank you. We have another Q&A. Can more engagement guidance compensate for time constraint in education? In which situation should learn by doing be more important than theoretical design concepts? Anybody wants to respond to that?
I could respond. So this is Dominic. I've also just typed something into the system. I think it's not necessarily an either or. I think it's really about instilling a confidence within the students to be really very conscious about the processes that they undergo, really conscious about how they acquire knowledge with the equipment, with the software, how to combine that in a very natural way across different sort of domains. And therefore, I think it's really up to the educator to help the students to acquire that sort of critical standpoint and to be able to reflect on their choices of tools and the purpose behind that. So there should always be a purpose for the tool and not the other way around.
Okay, thank you. Anybody wants to relate to that? Please, we have last 5 minutes. So in fact, we have like 3 minutes for more discussion. So please relate to that question. Even we discussed much more of the education than the rest, but I think we touched all the questions here.
I think I will just add on to the points which Dominic had, because currently this question actually relates to architecture a lot more, because we need to do a lot of hands-on to understand the texture of the materials and all these real things instead of just having the how do you put that? So you have to really experience the whole process and touching the materials and really going through the thing to really understand it. So like what Dominic said, this is not either or, but you can actually teach the theory and the hands-on together so that they can pick it up fast. And I think it actually really can to some extent compensate, but as what the question said, compensate the time constraint in education.
Mm-hmm. Thank you. Anybody wants to relate to this or ask? Anybody has a burning question? As said to everybody, please use Q&As. We have one more Q&A, maybe?
We have actually one question from Patrick to Dominic. Okay. I think that question really worth answering.
Yeah.
The question, I put the question on the chat. So yes, the question was, what do we really mean when we talk about post-digital, since most students cannot do any programming whatsoever? And, is there, do we need more specific terms? If we're talking about computational thinking, if we're talking computational thinking, we're usually including some kind of programming skills. If we're talking digital, well, you could just be using Photoshop and that's digital. So does, Dominic, do you have any thoughts on that?
For us, it's not necessarily, sorry, I need to, For us, it's not too tightly defined, to be honest. It is very often related to simply working as a matter of course between different tools, either in choosing the right tool for the right purpose and understanding your tool ecologies. And in that sense, not focusing on something now being digital or not, but really focusing on the task at hand and being quite aware of the choices that you have as a designer of how you approach this, and then really being able to maneuver quite fluently from one tool to another, from one medium to another. But I think that's not something that you automatically get, particularly as a student. That's something that we as educators have a responsibility to assist the students with in the way we teach, where we possibly have a lot of technology skill that we introduce as part of the studio teaching and not as a separate add-on sort of course. Or maybe we can also have it as a separate add-on course, but we link the two together as much as possible. And these were some of our observations.
Okay, any more comments, questions? We have like 1 minute if anybody has burning something burning going on.
Can I just add a small comment on the previous discussion?
Yes, please.
I find the term post-digital very confusing and maybe misleading, because it sort of seems to imply that we're moving on beyond the digital, but maybe it's better to just clearly state that the digital is no longer the topic in and of itself, but it's now able to plug in with other kinds of design problems, right? Just as a sort of undercurrent. And I find it very interesting right now as we're in the summer, you know, preparing courses for next semester, and in Hong Kong, we're getting ready for more online teaching, unfortunately, thanks to the pandemic. So actually in a more digital rather than post-digital reality, and maybe the question is more how we can still incorporate some other more traditional crafts like hand sketching or conversation as part of thinking and brainstorming, rather than letting students work very individually through a series of digital exercises. So yeah, my point is how to integrate. Yeah.
Thank you. I think it's a great point to close this session, because we have to finish very sharp, because I would like to invite everybody for the next session that is on robotics, chaired by Hank Hausler, and it starts right now. We don't have break between that, so please go to the program and go directly to the session of robotics. We have one more one more minute to close down, and thank you everybody. It was very great discussion. I was quite nervous from this session. I've never chaired this type of session, so I am very happy. To my mind, it went quite nicely. So thank you everybody. It was really great. Okay, bye.
Thanks, Marie.
Bye-bye. Thank you. Thank you very much, Marie.
Bye-bye.
Bye.
Thank you.
Bye.
So thanks, Marie. Great job. You've done fantastic. I'm nervous now and starting the session here. Unfortunately, I wasn't really able to change the background. My university settings do not allow me to change backgrounds for any Zoom meetings. So I either can have my personal background or a banal picture. So apologies for that. Quickly, I want to introduce myself. My name is Henk Hausler. I'm Associate Professor at the University of New South Wales in Sydney. I'm the Director in the Computation Design degree there, and I'm chairing the session today on robotics. So great to see you all here virtually. I would have loved to catch up with you all in Bangkok. It's like a family meeting once a year, so I hope we're going to see each other next year in a conference at Kadria again, or at other conferences later this year if they happen so. Today we've got a few presentations. I hope you had a chance to see the presentations before, but I want to give each of the panelists a chance to quickly, in 1 or 2 minutes, to introduce themselves and talk quickly about their presentation and their work, to refresh again what they've been doing. I will talk or call each panelist one after the other, going through the order as they appear on the homepage, and quickly ask them to present themselves and their paper. So I would like to start with paper ID 21, Charlotte Firth. Is Charlotte around? She's most likely not around. Ah, she raised her hand. Fantastic, Charlotte. If you quickly want to introduce yourself and the paper. Seems to be the first problem coming up there.
Hi, sorry, Hank, can you hear me?
Yes, I can hear you. Hey.
Hi. Sorry, my internet dropped out as soon as you said that. I've just rejoined. Hi, everyone. My name is Charlotte, and I was working on the paper Development of an Anthropomorphic End Effector for Collaborative Use on Construction Site. And I've just put a little poster here, which I will share on my screen here to give you guys a refresher if anyone hasn't seen it before. So basically this research looks at, it's focused on safe collaboration between humans and robots by developing an intelligent anthropomorphic end effector using soft materials. So this was kind of the preliminary step, looking at just silicon sensors that were readily available. And sort of different systems and how to actuate this. And we're exploring this to kind of find things that would be useful design for an end effector specifically for construction, because a lot of soft end effectors that have been designed currently can only pick up light objects, whereas in construction, a lot of tools like a drill or a hammer are actually quite heavy. So yeah, that's kind of this research project.
Good, thank you, Charlotte. Thanks for the presentation. It's very close to my heart because Charlotte and I worked together on the presentation. I uploaded the list of people on the chat so you can see when you're there, so you don't really get a shock. Bastian, are you here as well? Yes, I can see you. Good to see you again. Bastian, I met last year at CAD Futures, so good to see you and hopefully see you again in person. Bastian. You might need to unmute your microphone.
Yeah. So thank you everyone for sharing your time with me. So our research project was about, or the goal of our research project is to highlight the advantage of building or constructing with prefabricated elements or modules. And therefore we developed a set of different weight modules that would allow us to shift the center of mass within our assembly. And additionally, we went through an automated construction process, making use of a 6-axis robot with all the complexity of handling different modules, and finally built a small demonstrator that illustrates the possibility to build with differentiated weights within one assembly. The whole project is part of a bigger research at our university, at the Technical University of Darmstadt. I'm currently a PhD candidate with Professor Oliver Tessmann at the Digital Design Unit. Thank you very much.
Thanks, Bastian. Hope you're well there. Good to talk again. Next one is Joanna. Joanna, are you online as well? Might not. Joanna sent me an email before from Tokyo saying that she's got a few difficulties. So Joanna, if you come later to the session because you've got challenges, please quickly write in the chat and you can present yourself later. Next paper is paper ID 62. Philip Yuan was the lead author. Is Philip here or someone that represents Philip? Looks like not. Next one is paper ID 78. Gabriela.
Hi, everyone.
Yes. Hey, Gabriela, how are you doing?
Good, thank you. Very early here in Edinburgh, so up and going. My research was looking at how we can use robots to reimagine joints for CLT panels. So it's well known that the joints in CLT structures are the weakest link. They often take a lot of metal fasteners to bring them together, lots of manpower, lots of hours. So I was using robotic technology to mimic traditional Japanese joints and see how we can create a timber on timber joint that is strong enough to keep the panels together without the need for exterior metal fasteners, and hopefully reduce wastage as well in the process by using panel offcuts in factory settings.
Fabulous, thank you. And sorry, Gabriela, before that I just sort of ignored you or not included you in the list. It was a bit rushed. Next one is paper ID 132. Carolina. Carolina, are you with us? Does not look like. Carolina? No.
In the room.
Pardon me?
Good morning. My name is Karolina Dąbrowska-Żółtak.
Hey, Karolina.
I was writing about the idea of Robotown. We had implemented this idea of looking for a place for robotics somewhere between scale of architecture and urban planning, and we were implemented in educational area where students had have to prepare a project of capsules dedicated for seniors, and they prepared a project for capsules both in the scale of in the space of suburban area, but in the second edition they are concentrated on more urbanized areas, and prepare a solution of future implementation of robotics in scale of dwelling, in scale of separate capsules, and in scale of multi capsule megastructures, which combine this kinetic architecture, mechatronics background that students were received during the beginning of this studio, and in the final part of the studio, students had to prepare responsive models, preparing basic stuff like Arduino and motors and sensors, which help them to find how mechanical problem that can deal in the future, when they will prepare a project connecting kinetic elements, and also we have asked them to prepare their own algorithm dedicated for Arduino to make this process working.
Thank you, Carolina. Next one will be Yiheng. Is Yiheng in the audience?
Yep.
Yep.
Can you hear me? Hello.
Hey, yeah, I can hear you. Hello, how you doing?
Hi. Hello, everyone. My name is Lin Wei, and I'm representing the collaborative team of Fengjia University and National Jiao Tong University for the paper Transient Materialize. Our research is mainly focused on extending the traditional metal curving technique, and which only allows the production of like a planar curved material, which with a 6-axis robotic arm, we're able to perform spatial curving to a metal rod, which basically can reproduce any 3D curve as long as the curvature is fitting the flexural abilities of the material. The motivation of this research is realized on the demand of the precise 3-dimensional false work in the various purpose in architecture, such as a false work for most novel digital fabrication development, or constructing a curved concrete structure of a full-scale architecture nowadays. With the technique we have developed, it is possible to rapidly represent a complex surface with metal rod, which these rods no longer limited to representing the horizontal or perpendicular cross-section, and now can be any curve without limitations. For example, optimizing to represent the force line distribution of a surface, which leads to a better overall structure performance with less material. Thank you.
Thank you, and thanks for joining. The next person on the list, quickly for introduction, is Abraham.
Hello, hi everyone. Let me try to share the screen. Okay, can you hear me and see the screen?
We can do both. Thank you.
Awesome. So hello everyone. Again, thanks for having us. So my name is Ibrahim Sinci. I'm Assistant Professor of Architecture at Kent State University, and I'm a Director of Robotically Augmented Design Lab. So I'm here to present or basically quickly talk about what we have presented virtually in terms of the paper that we have. So it's part of a bigger research on hybridizing digital and physical as a design medium. So we are seeking a new medium for design, which is kind of physicalizing digital and digitalizing physical. And the project is looking into architectural massing project as a hybrid puzzle of components and pieces, borrowing ideas of super components from Tom Biscomb's and Triple O conversation. Students in my lab, Tyler and Josh, they developed a project that looks into animated chunks of building that recompose or reconfigure itself. And to just physicalize that idea and to bring that animation, digital animation qualities into physical environment, we tested that at the desktop scale for now. But I mean, virtually or conceptually, the idea is scalable because of the fact that the same system of robots can handle up to 2 tons, which is the same kinematics and same inverse kinematics, so on and so forth. So that's really a brief, synopsis of what we have done and what we are developing more or less at this point about this project.
Cool, thanks so much for that. It's very insightful, and thanks for joining the session. Amar is the next one, paper ID 375. Amar, are you in the audience as well?
Yes, can you hear me?
Yes, hey, how you doing?
Great, thank you. I don't think I have controls to share my screen. I don't see it.
I can't see what you can see. So I'm not sure. Normally when you go down to the bar at the bottom, there should be a share screen option.
Yep.
Yep, good.
Can you see my screen?
Just wait for a second. Yep, we can see it now. Perfect.
All right, so basically I'm presenting or summarizing a paper that I wrote with Ken Tracy and Mark Tam, and it's basically robotic sand carving machining techniques derived from a traditional Balinese craft. And it's basically looking at a traditional craft found in Bali, where they use this sand, beach sand that's rich in magnetite found on the beaches, with kind of very simple tools, and they mix it with cement mixture, wait for it for a bit to harden, and then start carving it. And after a while, it solidifies. And all the work is done on tempos in place. And what we try to do is take that and simplify it for a robotic kind of machining process. The work presented is basically in very early stages, but we showcase kind of a number of different prototypes that we went through, and kind of some of the results that we did as part of this research. Thank you.
Fabulous, thank you. Very close to my heart, and maybe we've got a chance later to discuss that in detail. Brady Peters, ID 421, are you in the room? Might be not. Brady from Knowledge is in Toronto, so it could be a challenge to, keep the time zone up. I think we've been really spread around the world. Christian, paper ID 434. I've seen you before.
Yeah.
Yeah.
Can
Hey, Christian. How you doing?
Good. Let me share my screen. Do you see it?
Yep, I can see it.
Okay. Okay, yeah, hi everyone. My name is Christian Lang. I'm associate professor here at the University of Hong Kong, and I'm just quickly sharing our paper entitled "Reformative Coral Habitats: Rethinking Artificial Reef Structures Through a Robotic 3D Clay Printing Method." The paper is written with my team members Lydia Ratoy and Dominic Coe, and it is actually like a collaboration between the Faculty of Architecture's Robotic Fabrication Lab and the Swire Institute of Marine Science here at the University of Hong Kong. And well, now it seems like, oh yeah, so 2018, Typhoon Mangkhut hit Hong Kong, and the city lost around 80% of its existing corals. So as a consequence, we met like as a team, we created this team between marine biologists and architects to develop a series of performative structures that have that will be, or that have been actually deployed this year, and intending to aid new coral growth over the coming years. The paper describes the present research that focuses on design and fabrication of artificial reef structures, utilizing robotic 3D clay printing methods, addressing the specificities of Hong Kong marine ecologies. And it describes further the algorithmic design methodology, the optimization process in the generation of the printing pass, and the methodology for the fabrication processes during the production cycle to achieve an even quality and prevent cracking during the drying process. So I'm going to just flip here through some of the images. Here you see like how it has been deployed just like a couple of weeks ago, and they're kind of like now implanting these coral fragments into it, and they're supposed to grow there for the coming couple of years. That's about it.
Good, thank you, Christian. Also, very, very close to my heart. We do a very, very similar things, but for different species than corals.
I see.
So I'd love to have a chat with you later, because you probably have faced or will face similar problems that you have faced. Ming Lu just wrote me a message and said that Ming Lu is in the audience, so I'm just going to quickly hand over to Ming Lu. Is Joan Wang in the audience? So Ming Lu just said hi to me, but I can't really hear Ming Lu. Ming Lu, you might need to open up your microphone. We can't hear you. In that kind of case, we're quickly going to go, let you fix the problem, and going to go to Teng, the last paper, paper 436.
Hello, can you hear me?
Yes, I can hear you. Hey.
Hey, everyone. My name is Ten. I think I should still share my screen. I noticed the presentation link wasn't functional. Hello, everyone. My name is Ten. I'm from Cornell University. So my paper is about how to make a robot, personal robot for fabrication tasks. Because we found for individual designers who have not trained with computing skills, it is very hard for them to use a robotic fabrication tool or a digital fabrication tool to conduct the fabrication task. So for our study, we are trying to make a new configuration of the robotic arm, which would be easily to be used by those designers who have no computing background. So this robotic arm is fully 3D printed, and also we not only we finished the hardware design fabrication, but also we made a series of the grasshopper component that it can be controlled, that it can control the robot directly through the modeling software, which is Rhino and Grasshopper. Because it might be easier for those designers who have not trained with computational skills, for them, because they don't need to be controlling those robots through our robot programming software like Rabbit or Kuka. So this is what we are focusing on, making a new robot for a sketch level prototype.
Great. Can you share the cost? Would it be to build a robot like that?
Yeah, the cost for this one, it costs about $800 US.
Bargain. Being in a very tight, cheap university environment at the moment in Australia, any money saving would be good. Thanks for your presentation. I'm going to try again with Ming Lu. If Ming Lu is here, she tried to raise her hand and we looked for a raised hand,
hello.
but we couldn't find it. Yes, hey Ming Lu, how you doing?
I'm sorry. Now I can hear you. Can I present now?
Yes, yeah, please.
My Can you see my screen?
Yeah.
This is my paper. My paper is for a new algorithm to get optimized target plane on 6-axis robots for fabrication. Usually we get some, if we want to print a curve, we can see some, the default target plane is in this kind, but it's not a good effect. If we use this kind of target plane, it's we can get better results. But it's not efficiency, because we have to try a lot of method to get this effect, because when we find when the axis 4-axis is near to 0, the effect is better. We can see finally we find an analytical solution to make these things very efficiency. We can see the default kind. When we use default, you can see this graph of angle very much change. But if we use optimized target plane, we can see the axis 4 doesn't change, doesn't rotate, and we can see the angle is not change so much. This is a better result. You can see you can compare, and you can download this component from Food for Rhino and use it. Thank you.
Thank you very much for your presentation. Again, one last time for John Wang. Are you around? If not, then I would like to use the rest of the session for a panel discussion to discuss with you 2 questions. I'm going to post those questions in the chat as well. The first question really is that the conference theme is design in the age of humans, but yet you use machine for your design. So I'm quite curious in discussing with you, how do you see the role of the interaction between human and machine in your design? I think there have been a few examples where the human have a stronger role in there, and some of them are weaker. So do any one of you want to pick up the discussion of how robot-human interaction is happening in your design, and does it influence your design?
Maybe I can quickly start, because I think that's one of the main focuses of our lab, or RAD lab, as a way to kind of precisely question the same question in terms of human-machine interaction, but not necessarily as something that has been practiced for maybe past 30 years, which is the use of robots and machines as smart and strong workers, or using them for mainly, which is very important and obviously valuable, but using them for fabrication, but also trying to turn them into collaborators or some sort of agent in the design process. So I think to your question and back to our project, I think one of the main goals, whether we achieved it or not, at least one of the ones that we set, was trying to bring the feedback loop into the game as a way to learn from the robot as well as teaching it. So I think this mutual interaction, whether it's happening conceptually or real time or offline, I think that was one of the intentions as a way to question the same question that you're proposing, in terms of the agency of the robot in opposition or in collaboration with the human, as a way to create a collaborative and I don't mean it in a technical word necessarily, collaboration in terms of a real-time communication, but also in terms of a real-time not real-time, but offline or online agent that modifies the design process as it moves forward. So rather than it becomes a producer or a product, it can become a part of the design process that impacts the process on the go. So I think that to your question was or is at least the way that we are currently looking at the question.
It is, yeah. It's to really see the robot as a co-worker, as a collaborator, as a sort of social being that can interact with us and design and fabricate with us. But obviously there have been various constraints then coming up in that as well. Anyone else has an opinion, an idea on that topic? Yes, please, Bastian.
Yeah. I mean, I totally agree with Ibrahim, and I think what is sometimes, or what we will see more in the future now is more robotic-centric design. So, although maybe there might not always be direct interaction between the machine or the robot and the designer, like a hands-on approach, but already the way we think is affected by those machines. So what we are trying to push is really for designers to design robot-oriented. So as we've seen in our paper, previous research might have just stacked, in great examples, bricks on top of each other. But what we will see in the future is that we will see more complex construction plans with maybe 50 different elements that have to be stacked. And you have to design those stacks. And that is already shifting the way we as a designer have to think about the elements that have to be assembled. So I agree that there will be a lot of interaction directly with machines, but also the way we think about the design will be shifted even more by the robots.
Yeah, it's actually an interesting kind of thought where I was listening to a podcast the other day on essentially computers for the longest didn't have any senses. So a computer couldn't really hear or couldn't really see, but now with computer vision, a computer could see. Through native language recognition, the computer could hear and could make sense about it as well. So suddenly computers have senses as well. So one sense obviously that comes to mind with a robot arm is the sense of touching, that suddenly your robot arm with a sensing device, and Bastian, you showed some work on that, and that influenced quite a lot was what I discussed with Charlotte on the idea of that there could be a fingertip of the robot's arm that senses, and suddenly you could work better with that. Is that important for other people's work as well in robotics?
Well, for me, it's kind of like, I mean, maybe not so much like in this project, yeah, because this project is this collaboration between the marine biologists who had like, obviously like a brief given to us, like what they want to achieve with these tiles, yeah. And so we were kind of like focusing on achieving that with the process we have, yeah. But like, nevertheless, the process, which is direct ink, writing, printing, is still, of course, like limited, and we are kind of using that limitations, obviously, as well creatively. But usually, when I work with, I mean, I have done a few projects now with clay and 3D printing. Usually, what I'm interested is to really understand what actually the process itself can bring to the table. Yeah, so that I would say is this kind of form of discovery. But for me, mainly. Maybe that's even not new for architects, yeah, because I think like architects are really kind of like working very differently with robots than anybody else. Yeah, everybody else is just using them as kind of executable machines, yeah, like to kind of like do the job. Whereas we kind of see always this within the process, like an opportunity, yeah, and to see like, okay, what can it bring to the table, yeah. And I think in my work, at least, it's kind of like very important to see what the process, which is somehow a development out of trial and error, yeah, is starting to bring to an aesthetic of a brick or whatsoever, you know. So, and I would say also that's even not new in architecture, because like if you look back into the Bauhaus era, Walter Gropius was basically also like, he was kind of like really interested in new technology, but he didn't want to use the new technology to build old architecture. He basically wanted to use this new technology to represent as well that that era of society.
Yeah, I think when you mentioned clay 3D printing, and because we've been working on a marine biology project as well, where the geometry was so complex that at the end with traditional 3D printing of clay without a support structure underneath that, you couldn't really 3D print it anymore because there were so many overhangs in the geometry that suddenly we needed to have the help of a human, where the human interacted together with the machine and understood where the human needs to support the robot in its printing effort by putting substructures in there. There wasn't really a sense of sensing or communication between the robot and the human. It was just some experience the human have made of understanding when the print process failed and becomes spaghetti ball when the human has to interact. But I think there's a lot of interesting ways of engaging with the robot and the human, particularly now with collaborative robotics around, that have a sensing device that can sense when you've been around, so you don't have to cage them anymore. You potentially could train them of having a different way of thinking about you as the designer and the robot as a designer, and working together. So I think there's definitely a huge advantage to look into that. If there have any other kind of comments, please go so, and I'm going to post them the second questions into the chat as well. Does anyone follow up on that?
I do have some other opinions regarding to this matter. Because the first thing I want to say is for the digital design fabrication technology now in the age of human, I would say maybe we can switch the term a little bit. That the digital fabrication could evolve to distributed fabrication. Let's say during this pandemic, everyone's staying home and working from home. But if you're a heavy robot user, it will be very challenging for the designer to access the industrial robot. I'm thinking about maybe we can somehow working on developing a new kind of workflow that you can use your own device like this, like the 3D printer, with relatively cheaper price for doing those kind of robotic fabrication tasks at home. So turning digital fabrication into distributed fabrication might be another potential during this challenging time. I mean, the pandemic.
Yeah, thank you. I just was reminded that we've got 10 minutes time. So the second question and last question is, the age of Anthropocene have resulted in a lot of challenges. Now I'm living in Sydney here. We had this year nearly everything that you could expect. We had bushfires where we couldn't really see out of the window anymore because the half outside the bush was burning. Then the bushfire stopped, and then we had a flood. Then we had the pandemic. So we're just going to wait now for the next thing to happen. If anyone got any suggestion what could happen next, please let us know. We are prepared for that. So do you think you can use robotics or robotic design to answer a larger question, and the robot is the vehicle to address that question? I think, Christian, the work you've shown with it's really, there's a problem that comes out of climate change. There was a group of people that had a problem and they couldn't really solve it by themselves. So they came to you as a designer and an expert in robotics to fabricate things. Can you see other issues where you say, well, it's not just the robot in the foreground that you want to fabricate something for the sake of fabrication, but there's a very clear agenda before that?
Well, I mean, for us, it's so this current research project we're doing is based on actually identical tiles. Yeah, I mean, we printed around 130 tiles or so. Yeah, and there are two types of tiles, and they had to be identical because this is an experiment. Yeah, so the experiment is to see whether any of the corals we are implanting there has a better survival rate when they're kind of like in combination, like with if there's two kind of coral types or three coral types, or like just a monoculture. So for that kind of purpose, they needed to be identical kind of to get valid information. But we are planning right now a second iteration of that, where we actually kind of thinking of making every tile or every artificial reef different, to really also understand whether now space, space and patterns so have any kind of like specific impact on the growth of the corals. Yeah, so that leads us to kind of like where we are with robotics. Is kind of the advantage of robotic fabrication is that you could kind of do every tile or every component like an individual unique tile. Yeah, and that's kind of like, I would say, also like when you look into coral research, it says like that 50% of all kind of artificial coral reefs don't meet the requirement. Yeah, like in terms of they don't kind of enhance the kind of survival rate of corals or so. Yeah, so that's obviously quite interesting to see like that you could kind of tailor a very specific solution for a very specific context. Yeah, and so like in our case, for instance, now in Hong Kong, which is a metropolis, harbor or waters. Yeah, so it's quite dirty waters. There's a lot of sedimentation in the water, so you need to kind of design your tiles in that way. Yeah, so I would say, the robotics obviously gives us the opportunity to kind of then address like really like these bigger kind of like challenges we are facing right now. Yeah, so, and I would say, I mean, that's kind of where we are trying to head with our kind of research right now, to kind of be very specific to a condition, you know.
No, that's where we've seen using the robot as well. We use very site-specific data, and then out of the site-specific data generate a geometry. So the geometry is always different, and therefore you need a great amount of flexibility in the fabrication. So a tool that can fabricate whatever, so either subtractive through CNC milling or then adaptive through 3D printing. But are the other people, you know, is concerned, Sebastian, of climate change driving your thinking or your way of designing through the robot?
I mean, climate change, in a way, yes, because what really got me interested in robotics is what you mentioned also earlier, this extension of the digital into the physical. So this, the possibility that, I mean, we are all used to computers all the time. And what is really intriguing to me about a computer is that I'm able to change everything all the time. And that's where I see what we would like to, or where we would like to challenge architecture a little bit through the use of robots, is that this editability, that we can edit things as fast as in a computer. I would like to see that happen also in the built environment. That's why we are looking a lot into modular structures at the moment, things that are dry fitted, so you can disassemble them very easy. Because I'm from Frankfurt, and in Frankfurt we just demolished almost 100-meter high high-rise building made from concrete, and it was just exploded. And the question is, and now they rebuilt a very similar tower at the same spot. And I was always wondering, why didn't they just take the parts, move them a little bit to address new spatial needs or something? So in a way, yeah, that's also an answer to some climate changes, because the way we deal with our materials at the moment and just grind them down to smaller portions and downsample them, downcycle them, that shouldn't be the answer. So my big dream of all these robots in built environment is that we have a faster editable built environment around us in the future.
We've got 4 minutes. Other people want to comment on that as well. There was Amma, please. Yeah.
As Sebastian was saying, and it's such a fun conversation to have at around 4 a.m. here. But I think, I mean, just to sum it up very quickly on my end, I think it's also a social political question, which kind of connects into that conversation about editability and so on and so forth. So I think we can also consider, I mean, it's awesome that we have answer to problems, but we can also question the problems, you know, themselves right out of the bat from the beginning, how we kind of try to, you know, like make less problems, let's say. And then maybe I think it's becoming a social political question. The conversation that Bastian is bringing up, I think it's connecting to the discrete conversation with some of the work of Gilles, Jose Sanchez, so on and so forth, that are questioning technology in relation to, politics and commons and so on and so forth. So I would keep it short so we can have a longer discussion with the rest of the panel.
So Amar had one last comment, being mindful, and I just seen Yasushi had a comment as well in the Q&A session, but Amar, quickly comment.
Yeah, I think the issue isn't really kind of using robots as a vehicle to address these issues, because at the end of the day, robots are a tool and one of many tools that we have in our kind of toolkit as designers and architects. I think for me, the more exciting things when it comes to robotics and construction, for example, is on-site work. And you can divide that into two categories, ones that could be automated, like bricklaying or kind of putting units in place, and others that are a little bit more sensitive and require kind of craft. So what we were looking at in terms of kind of taking a kind of carving craft and trying to digitize that or simplify it in a way. One of the key kind of aspects about that craft is using local materials. By using local sand, and we tried kind of different sand mixtures. If we imagine in the future, we can have kind of an on-site robot, and then remotely a craftsman can operate that, much like surgical robots. So that's a slightly different way of using them on-site through kind of this virtual engagement with a material that's easily kind of applied on site, and then you have kind of professional remotely operating these machines.
Sorry, I would love to have a longer discussion with you, but we've been very, very clearly guided on time. So we've got 1 more minute before the next session starts. So we have to get up. If you want to go to the chat room, I would love to have with you a longer discussion. I'm going to go to the Kadria 25th anniversary exhibition chat room, and maybe we can continue the discussion there. Again, thank you much for submitting your papers to Kadria. Thank you much for joining that session here. And I hope I'm going to see you all in the chat room or in person next year in the next Kadria conference in 2021. Thank you. Bye-bye.
Thank you very much.